All right, we're going to look at writing equations for word problems. We're not going to solve today, but we do want to write the equations. If you cannot write the equations correctly, then even when you go to solve it, you'll get the incorrect answer. All right, so this is our focus today, is just to write the equations. So the first problem we have is the perimeter of a rectangular city is 94 miles. If the length of one side is 1 mile less than 3 times the width, find the length and width of the city. So a typical word problem. All right, most of us go right for find the length and width of the city, and we try to guess and check, and we try to answer that question before we even come up with an equation that would help us to get that answer. So whenever we're dealing with perimeter problems, or anything that involves a shape, a rectangle, a triangle, okay, a quadrilateral, a four-sided figure, a square, what you want to do is draw a picture. So it's a rectangular city. So we're going to draw ourselves a picture of a rectangle. Okay, so sketch it out. And in this case, instead of making a chart or a table to solve a word problem and get set up, we write everything on the actual figure. So the first thing I notice is that we have a perimeter. So I always take that and I put it right inside my figure. That way I know what it is, and it's miles. So I'll put the unit here just so I know for the end answer, when we do solve it, we would have the units available. All right, so now we tackle the problem, okay? So we know the perimeter is 94 miles. We're done with that, so check, got it. We move to the next sentence, and it says if the length of one side is 1 mile less than 3 times the width. So what you have to ask yourself in every word problem is what is being described and what is not. So you really want to know what you don't have any information about so that that becomes your variable. So we're talking about lengths and widths. So the length of one side is 1 mile less than 3 times the width. We have a description of length. What we don't have is information about the width. So what we'll do is write in the word problem is we'll cross out the word width and we'll put X or W if you prefer. That's fine too. All right, and now we reread it. If the length of one side is 1 mile less than 3 times X, okay, because we've gotten rid of the width and it's now known as X. So now we're back to translating a sentence into an equation. We have a description of length. Now, when you're dealing with a rectangle, all right, one side is obviously longer than the other. Length, it means long. It's associated with the word long. So I'm going to put my width here on each side, because if we remember, perimeter is adding all the sides together. Okay. All right, now let's go for what the length is. So we got our width down there, and our length is 1 mile less than 3 times the width. 1 mile less than, if you recall from our translating sentences into equations, 1 mile less than means minus 1. So we're going to subtract 1 from 3 times the width. Well, how do you write 3 times the width? Well, this now becomes 3x. 3 times the width is exactly what it says. So we're 1 mile less than that. We're subtracting 1 from 3x. So our length is 3x minus 1. And since we have 2 lengths in a rectangle, it's 3x minus 1 down here. Now we are in business to write the equation of this for this problem. Now, as we said before, perimeter is adding up all the sides of the figure, no matter how many sides it has. So I'm going to start at the top, and I'm going to say 3x minus 1, got that guy, plus x, got that guy, plus 3x minus 1, got that guy, plus x equals 94. All right, so we're going to write it down here a little bit so we can see it better. So it's 3x minus 1, that's the top, plus the x, which is the width, plus 3x minus 1 again, plus the x on the other side for the width, and it equals 94. Now, you may be in a good position where you know you can combine like terms, which means that you can put all the x's together and all of the numbers together. If you are at that point, that is fine. You can combine those like terms. If you're not sure how to do that, that will be another lesson when we have to solve equations. Then you can just wait. I will accept this answer, or you can combine them. So if you do know how to combine, I've got 3x plus x, which is 4x, plus 3x again, which is 7x, plus 1x, which is 8x. So we have 8 x's. Then I'm subtracting 1, and I'm subtracting 1. And since I have 2 1s that are being subtracted, I am subtracting 2. And that equals 94. So either one of these is acceptable as an equation for that word problem. All right, so again, any perimeter problems, instead of drawing a chart, you draw the figure, you write all your information on the figure. Next problem. You run into problems about mileage, okay, trips. Okay, so let's tackle this one. On a 520-mile trip, Greg and Jessica shared the driving. Jessica drove 80 more miles than Greg. How far did each person drive? Well, in this case, this does not involve a figure. So we need a chart. So we draw a chart with the 2 people involved, Greg and Jessica. What we do know is they have a total number of miles that they drive. That's it. So this is total. So I like to write some information above the words in the word problem. All right, now, Jessica drove 80 more miles than Greg. So again, you ask yourself, who do you have information about and who don't you have information about? So this says Jessica drove 80 more miles than Greg. So we have information about Jessica, but we do not have any information about Greg. So he's the unknown. And in algebra, when you don't know or you have an unknown, you make it x. So we're going to cross that Greg out and we're going to make it x. It's a safe variable to stay with, but if you wanted to, you could use g. All right, so we're going to put Greg is x, so we're going to put x in the chart for Greg. That's his amount of miles. We don't know how many he drove, but we do have a description about Jessica. Jessica drove 80 more miles than x. Well, more miles means plus. So 80 plus x. So Jessica drove 80 plus x. And that's her total number of miles. So now we need an equation. We know that they went a total of 520 miles. So basically what we have is Greg plus Jessica equals 520 miles. Greg is x plus Jessica is 80 plus x. And it equals 520. And that's your equation. Now, again, if you do know how to combine like terms, you've got x and an x, so you've got 2 x's plus 80 equals 520. But if you don't, or you're uncomfortable with that yet, you can leave the first equation. It is acceptable. And remember, right now, we are not answering these questions. We will be at a later time. But right now, we're just learning how to set them up. Because again, without the equation, the correct equation, you will have the incorrect answer. And one more problem, and this involves ages. Okay, age problems. Jenny is 3 years older than Esteban. Esteban is twice as old as Jake. And The sum of Jake's age and Esteban's age is 81. So we got 3 people involved here. So again, we're not going to draw a picture, but we're going to draw a chart. So we have Jenny. We have Esteban. And we have Jake. All right, now we have to figure out who do we have a description of and who don't we have a description of. The person that we know nothing about, not even a description, will be our X, the unknown. Well, we have a description of Jenny. Jenny is 3 years older than Esteban. All right, so we know something about Jenny. We'll get to that in a minute. Esteban is twice as old as Jake. So we also have a description of Esteban. Who we don't know is Jake. So we will cross out Jake's name, and he's X. So I'm going to put X in our chart for Jake because that is his age. Okay, Jenny's 3 years older than Esteban, but we don't know anything about Esteban yet. So let's keep reading. Esteban is twice as old as X. Twice as old means 2 times. So this is 2x. So Esteban is 2x. Now we can go back to Jenny. Jenny is 3 years older than Esteban. Well, we just said Esteban was 2x. Jenny is 3 years older than that. So older than means plus. So Jenny is 3 plus 2x. So we'll put that in the chart for Jenny. Now we're going to create our equation. And you have to be very careful of the wording of the problem because it's going to tell you how to create that equation. Don't just assume that Jenny, Esteban, and Jake total up to 81. Read carefully. The sum, which means we're going to add something together, of Jake's age and Esteban's age is 81. Only these guys. So this is Jake plus Esteban equals 81. Jenny is not in the picture here as far as building the equation. But once we know what X is, by solving this equation, we can substitute it and get it back. And we'd be able to find Jake's, Esteban's, and Jenny's age. But she's not part of creating the equation, so watch the wording of the problem. All right, so Jake we know is X. Esteban is 2X equals 81. Again, this is a valid equation from the word problem, but if you are comfortable and you know a little bit more advanced on how to combine like terms, X plus 2X is 3X equals 81, and I'll accept either one of these two. Again, we're not solving at this point. We're focusing solely on the word problems just to be able to create the correct equation, because if we don't have the correct equation, we cannot get the correct answers. Okay, so when you're working these word problems, cross out the information, replace it with variables, numbers, and symbols, and then put them into your charts or put them onto your figures and create your equation based on what the words are saying. And that is how you write equations from word problems.